Hey everyone, CNC Keith here. Hey, I'm getting a lot of questions about the encoder port on the Acorn CNC control board as far as what type of encoders to hook up and how you hook up an encoder and get it running with the Centroid Acorn CNC control kit. It's pretty easy. All you need is a quadrature differential 5-volt encoder. These are very common. This particular one I have here is a Tawagama Seiki FA coder, and it's a 2000 line encoder, which means it's 8,000 counts per rev. And I just took an old broken 1/4 inch cutter, because this is a 1/4 inch diameter encoder, and tightened down the set screws so I could turn it easy with my fingers. This particular encoder comes with a black flat 9-pin connector, which is a fairly common encoder connector. And Centroid makes encoder cables. Now, you could make this encoder cable yourself. It has a Db9 connector on one end, which matches the Db9 connections on the Acorn board. This is also the same cable that's used on the Oak and all-in-one DC CNC control boards as well. And on the other end of the cable, it has the mating 9-pin flat connector that connects to the encoder. Now, the Db9 connections, if you're going to make your own cable, are right on all the Acorn schematics, and it shows you what pin numbers are what and what wires go where. So if you're going to make your own cables, it's also very important that you get the shielded cable and connect the shielding in the proper way. There's some pictures on the forum as well to do that sort of thing. But boy, purchasing this cable goes a long way, and I find it very cost effective, actually, so I don't have to bother crimping and soldering all these little connections. So to connect up the encoder, all I'm going to do is put this flat cable together and plug in the Db9, and then we're going to go over into the Centroid CNC Wizard and show you how to set that up. Okay, I just made the connection here on the flat cable, and I'm going to power off the Acorn board just as a precaution, and I'm going to plug in the Db9 connection. Now, you should tighten down the little screws, but since I'm just bench testing here, I'm just going to plug that in. Now I'm going to go over here to the Centroid Wizard and fire up the Wizard. And under Spindle Setup, that tab, I'm going to select Spindle Encoder, yes, and then by the default counts is 8192. I'm going to change that to 8,000 counts per revolution. And then I'm going to come down here and click on Right Settings to CNC Control and say yes. Alrighty, and then I'm going to close out the Wizard. And now I'm going to power back up. I'm going to plug in the Acorn board, power it back up, and start CNC 12. Okay, when it boots up, it's always a good idea to hit the reset button just to clear out the software and get everything up and running. Whenever you power down the CNC 12 software and restart it, it's a good idea to hit that button to reset and clear it. And you notice up here on the screen it says Spindle 0. And if I start turning the shaft that I put in this encoder, and I'm turning it counterclockwise right now, check it out. We have an RPM readout on the screen. So that's how easy it is to get an encoder for the spindle hooked up to the Acorn. Here I'm turning it clockwise now, and you see a positive reading of RPM on the encoder. Now, another really cool thing is you can go into the PID screen, setup, config, and if it asks for a password, it's 137. And I'm going to hit PID, and in the PID screen you get the actual encoder counts. So as I rotate, I'm rotating clockwise right now, you see the encoder counts for the spindle counting up. Now I'm going to rotate the other way, and you see them counting down. Now, if you happen to be turning this in a clockwise fashion and it was counting the opposite way, that's a pretty easy thing to flip around. That means the A and the B channels on the encoder have been wired incorrectly, whether it might be at this connector or over when you soldered up the Db9. Now, if you order the Centroid cable, which sells for $85 and the stock length is 16 feet, you don't have that problem. You just connect it up and it works. But if the channels were flipped, you could do one of two things. You could unsolder and resolder everything to flip the channels around, or you could actually go back into the Wizard And remember when we typed in 8,000 counts per rev for the encoder in the wizard, you could actually put a negative number in there, and then the Centroid software would know that the encoder is actually spinning backwards relative to the actual spindle. So right here you would just put a negative number in for the encoder counts if it was spinning the wrong way. So that's how you fix that. And of course you'd have to hit right settings to CNC control here to make that effect happen. That's it. That's how easy it is to connect up an encoder to the Acorn board. Now I'm ready, now that I bench tested this encoder and it's working. You see that RPM there, I'm spinning counterclockwise, so I have a negative direction, there's clockwise. I'm ready to bolt this encoder up to a machine. It could be a milling machine spindle for rigid tapping on a milling machine, or it could go on a lathe spindle. And when you do connect up an encoder to a spindle, it has to be a one-to-one connection. So for every revolution of the spindle motor, one revolution of the spindle itself, not the spindle motor, it has to be on the spindle itself. You should, the encoder should also spin one revolution. So one-to-one connection. We're ready to put this on the machine and start threading on a lathe, or doing rigid tapping on a lathe, or rigid tapping on a milling machine. And then that gives us that true RPM display as well, which is really nice to be able to very accurately tune your VFD to get very precision RPM commands. So when you type M3S3000, it will actually spin 3000 RPM. Well, that's it. It's a pretty nice, powerful feature in the Acorn board. Hope you all enjoy that. Talk to you soon. Bye-bye.